All right, you made it. End of session 3 or module 3 of unit 7. Session 4, multiplying decimals. Today, what we're going to be doing is multiplying decimals. We'll be doing some work together. Okay, and then you'll need your student book, page 289. You're going to have, when we're all done with our lesson today, you'll have student book, page 290 to complete on your own, and then your home connections, pages 247 and 248. But before we get going, let's make sure you get out your student book, page 200, I believe it's 288. Yes, 288, and check over your answers. If you did not have the answers written down, go ahead and make those changes. If you have any questions on how we came up with those answers, please get in contact with us as soon as possible. All right, so now multiplying decimals. So we've done some work with multiplying decimals. Let's see if you can do some of these. Go ahead and pause your video, and in your notebooks, please answer the problems. All right, so welcome back. So if we're going to multiply 1/10 times 43, right? The thinking is, right, I need to multiply 1 times 43, which is pretty simple, okay? And then I look at my decimal that's over here, and I am multiplying by a decimal. What do I need? I have to move the decimal one spot to the right to make it a whole number, which means in my answer, I have to move it one spot to the left. Or you also ask, okay, how many spots behind the decimal do I have? I have one. You can include the 0, which would end up being 400.430, but it's still the same answer, correct? All right, so now what do I do here if I'm multiplying 43 by 2/10? Well, at first, I'm just going to multiply 2 times 43, which I know is 86, right? And then how many whole numbers are behind the decimal, not including the zeros. So I only have one number behind my decimal. So in my answer, I have to have one number behind my decimal. And I got 8.6. Is that what you got? All right. So now, how does it look when I multiply a decimal by a decimal? Well, I have, again, same problem here. So I'm going to end up with the same numbers or digits in my answer, but I have to ask how many numbers are behind my decimal in my entire problem. So I have one whole number here, and I have one whole number here. So that means I have to have two numbers behind my decimal, and I'm going to put a decimal point right here. Is that what you got? I hope so. And lastly, we have 0.3 or 3/10 times 4.3 or 4 3/10. And I get my answer. I can just multiply 3 times 43 and get 129. And I got to look at how many whole numbers are behind my decimal. I have one number here, and then two numbers here behind my decimal. So in my answer, I need to have two numbers behind my decimal. All right. So hopefully you notice that. And when you're working with decimals, it's just really multiplying the numbers that you know, and then figuring out how many numbers are behind our decimal point, and moving and placing the decimal back in our product. All right. So we're going to be doing some multiplication of decimals. Remember this? Remember when we worked with this? This would be 1/10 of a whole, right? This would be 1/100th of a whole. This would be 1/1000th, and this is 1/10,000th. If we think linearly, we can go across here this way. Same sort of thing. All right. So we have an area of a chip that is 0.44 by 0.44 meter or inches. What is the total area of our chip? So this is our array. All right, and we need 0.44. So I'm going to draw my line, and here's 1, 2, 3, 4, and then 1, 2, 3, 4 here. So I hope that that shows right there. So this is my 0.44, and then it's 0.44 meters wide. So I'm going to start here and then go over 1, 2, 3, 4, 1, 2, 3, 4, and I'm going to stop it there. So our area is whatever is multiplied by this and this together. What do you suppose that might be? All right, well, to get this as your answer, let's go ahead and put this up here. I'm going to add a text box down here. I am going to go 0.44, right, times 0.44. And then I'm going to draw my little line down here. Oh, maybe I'll just underline it. That'll be nicer. That'll be easier for us to see. And I'm going to use the standard algorithm because the standard algorithm is one that is more complete and concise for me. So 4 times 4 is 16. So I can go and put the 6. I'm going to carry the 1. Oh, we don't want to underline this though, right? And then 16, carry the 1. So 4 times 4 is 16 plus 1 is 17, right? So it's 176. And what I like when I multiply by a number that's similar, it makes it a lot easier for me because it is the same digits. See how that works? I just added a 0 because I'm multiplying by 4/10 and not hundredths. And then I will underline that, and then we will do some adding. So 6 plus 0 is 6, and then 7 plus 6 is 3. We're going to carry the 1, right? And then 1 plus 7 is 9. And then 1 and 1. All right, so this does not make sense, right? That I would multiply 0.44 times 0.4, which is a number smaller than 1, right? And I would get 1,936. No, remember when we're multiplying decimals, we do our normal multiplication problem, and then when we're all done, we insert the decimal. So how many numbers are behind the decimal here and here? Did you say 4? Right? 2 here and 2 here. So our answer has to be 4. So when we look at this answer here, we have 19 wholes. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there's 4 and 4. 16, 17, because I had to take 2 of this. And then I got 4 and 4. There's 18. And then I take a part of this one and a part of this one, which is 19. And then there's 3 100s. If I go back, there's 3 of these hundreds, and then 3 of these are thousands, and 6 of these 10,000s. Whoa! But if I were to look at counting up all of my square, that's what that would equal. So that square right there. Oh, I did not do a square. That square right here would equal 19%, or 0.1936 of that entire square. Okay. Let's take a look at this. Now I'm multiplying 1.2 kilometers by 0.63 kilometers. How can I figure that out? Well, maybe we try doing this. We do 3/10 times 0.65. And if I draw my shape, and what I'm doing is I'm going down from this to 3/10, right? And then I'm going to go over 0.65, right? So there's 4, 5, 6, 1, 2, 3, 4, and 5. So we want to figure out what the area is that is filled in, right? So if I wanted to count by squares, right? 3, 6, 9, 12, 15, 18, and then 18 and a half is 19 and a half is 20, right? So my answer for this problem would be 0.20, okay? But how can I use that information to figure out what 1.2 kilometers times 63 would be? It's very similar because I have the 0.3, but 0.65 would be 0.63, so that's a little smaller. Would my answer be greater than or less than 0.20? What do you think? All right, well, let's go ahead and try this out. So I am going to take 12 times 63 because I am not going to even think about decimals yet. Okay? 3 times 2 is 6. 3 times 1 is 3, right? 36. And I got to start with a 0 to go to my second row. 6 times 2 is 12. And then carry the 1. 6 plus 1 is, or 6 times 1 is 1 plus 1 is 7. So that's 72, but I have to add a 0 here. Okay. And now what I can do is I'll underline that, and then I will add my answers. Okay, 6 plus 0 is 6. 3 plus 2 is 5. So we're at 756, and that's my answer. But that is not my answer because I have to move my decimal point over, right? Because it wouldn't make sense that 1 times less than 1 equals 756. So we have 1 digit behind the decimal here, 2 digits behind the decimal here. You add that together and get 3. So in my answer, I have to have 3 digits behind the decimal. All right. So go ahead and have your student book, page 289, open. Make sure you get that completed. And what I will do is I will have answers for you tomorrow on our next lesson. When you are done, make sure, feel free to do any of our number corner and online resources for Unit 7. You have your student book, page 290, home connections 147 and 148. And again, reach out to your teacher if you have any questions. And if you don't, nice job. I knew you can handle it. And have a great day and enjoy math.